Alright, welcome everyone. I want to cover two concepts today. Two relatively short concepts that come from our economic growth section. The first one being this compound growth formula. The formula itself is very straightforward. As we're working through this, we have this general setup where you have your GDP at start date times 1 plus the growth rate of GDP. And important to note that this last part is an exponent. You can see that here when it's applied, we raise it to the power there. But that's usually the only mistake I see is people multiplying as opposed to raising it to the power of how many years you want to estimate it. And so what we're looking at here in this example, the example that we apply, you have your country, South Korea, with a starting GDP of 1.67 trillion. So just in the question, that is our starting GDP. And here is our growth rate at 2.8%. The important thing to note when you're using this compound growth formula, when you're applying it here, is that whenever you have this like 2.8%, that we need to convert this to decimal form when we're building out our formula here. So, two minor mistakes that I see. One, making sure that we raise it to the power and making that conversion into our decimal form there. As you're working through it, we can do like a quick example on this slide. So this one gives you a lot of breakdowns and it gives you a lot of opportunity to practice here. Here's your value, so your GDP at start date here is technically just 100, and then you're given all these different growth rates on the left hand side. And so what I encourage you to do is just take some time, just make sure that the calculations are coming out correctly. But the different columns give you your years. So the first column here, you're estimating 10 years into the future. Second column, we're estimating 25 years into the future. And the third column, we're estimating 50 years into the future. So for example, if I was trying to target this number here, this 1147, want to verify that we can get the same response, I need to take into account first my GDP at start date. So I would go 100, then multiplied by 1 plus the growth rate. And so because I'm working in this third row here, I'm using a growth rate of 5%. I make that conversion to decimal form. And I need to look at my column here. So I'm estimating 50 years into the future. I would raise that to the power of 50. And you should get that 1147. One thing to note is that if you're struggling with replicating that response, sometimes, depending on like the calculator, a lot of times if you're trying to use some sort of math AI system, the order of operations is out of whack. And so in order to simplify that process and to make sure you do it correctly, do this side first and then finish by multiplying by your GDP at start date. That gives you just a little bit of security knowing that you're executing the order of operations correctly. So that's it for the compound growth section. The more difficult concept in this unit is this idea of economic convergence. And so you have a nice clean definition here. So convergence is just highlighting the fact that our lower income economies, so countries with lower per capita incomes or lower per capita GDP, lower GDP per capita, grow faster relative to economies with high GDP per capita. And so we can see that generally, like if we break them into broad categories, we can see some empirical data here. Here's our high income countries. Here's our low, and here's our middle. Broadly, when we see these classifications, a lot of times these low income countries, these are our poor economies. These middle income, these are what we refer to as developing economies. And then the high income economies are what we refer to as developed economies. And so what we can see here is that we have two different, like, close to 10-year periods, and we're looking at the average growth rate between 1990 and 2000, and right up until the Great Recession with 2000 to 2008. Our high income or developed economies are growing at 2.7 and 2.3% respectively. Our low income economies are growing at 3.8 and 5.6% respectively. And our developing are experiencing the most rapid growth rates with 4.7 to 6.1%. And so if we break them broadly into these categories, we tend to see that this is true. It's important to note when we're talking about convergence, we're not talking about low income or developing economies meeting the same standard, meeting the same living standards as our developed economies. All we're talking about is their growth rates are moving faster, or they have higher growth rates relative to those with high incomes. So really careful there. Important thing to note is that there are economists who push back against this. And so I want to give the intuition behind both arguments. One, why would you think that economic convergence, like why would we use this data here and draw the conclusion that these economies are converging, and vice versa? Why might you push back against that intuition? So, first thing that you want to think about, arguments in favor of convergence. So why do we think it's probably likely to exist? Well, it's largely due to this concept of diminishing marginal returns. And so we have a nice definition here: easier to increase worker productivity starting from a lower base productivity. So what does that mean? Let's look at it in the figure. We have our output per capita on the y-axis, and we have our capital, which is our physical and human, so we have like our education plus our machinery on the x-axis. What we'll note is that these early entries, so when we move, like, we have these points here, 1, 2, let's call this point 0. As we're moving away from the origin, as we increase the amount of capital deepening, or put our physical and human capital into the production process, we get pretty big returns with respect to our output per capita. Each unit of capital is getting us pretty big increases in our output per capita, up from 0 to 1. As we go from 1 to 2, we put in more and more capital, but each unit of capital is getting us less and less output per capita relative to what we got between 0 and 1. And then let's say, for example, we have another one over here, another point, 3. From 2 to 3, now all of a sudden each unit, so we continue to get people with degrees, we continue to build new machines, but we're getting less and less output per capita. And so that's what that concept of diminishing marginal returns is highlighting. Is yes, we're continuing to increase our capital deepening, but we're getting less output for each unit that we increase. So it is possible to think about, like, the opposite side here, that an economy that's pushing up towards this frontier might end up having other economies catch up. So for example, like the US could be this technology 1, and as we hit stage 2 to 3, all the other economies who are growing faster, all of a sudden they increase their capacity to grow at faster rates and adapt these technologies. This is largely because whenever we invent something, so we go through the process of inventing different products with respect to our technology, like our Apple and Microsoft products, other countries don't need to reinvent the wheel. Those processes are already adopted, or even things like the assembly line. Those technologies can quickly be adopted, and other economies can begin the process to catch up as we, in the US, start to face these diminishing marginal returns. Now, the counter to this argument is that it is possible that the US is not stuck on technology frontier 1. So we looked at it in the last slide. If we're stuck on technology frontier 1, it's highly likely that all these economies are going to catch up with us relatively quickly. If we're able to continue to push this out, and I actually like this stylized slide here, and the US starts here at technology 1, other economies can start adopting our tech and they can start growing faster, but the US can offset those diminishing marginal returns by having further improvements in innovation. And from that point, we continue, now we have the process of diving deeper into things like artificial intelligence, etc. All these things can help push out our technology frontier from Tech 1 to Tech 2 and Tech 2 to Tech 3, which continually offset those diminishing marginal returns. So, important to note that it depends on our capacity to innovate. If we can continue to push that technology frontier out, then it's likely the case that convergence might not occur. But that also depends on the pace. If it takes us much longer to move from 1 to 2 or 2 to 3, etc., then we could see some of those economies begin the process of catching up. I want to make one final note with this. It's like, yes, I do want to make this point clear that we could see economies with lower per capita incomes continue to grow at much more rapid paces. And so we have an example here. Let's take this and just imagine it's the US. The US grows at an average of 2% over 30 years. We start with $40,000 for our GDP per capita. Grow at 2% over 30 years. With that maintained or that sustained 2% growth, in 30 years we'll end up with a GDP per capita of $72,450. We have another economy 2 over here, a poorer country with starting GDP per capita of $4,000. If they grow at 7%, so a really fast rate, and they sustain that 7% growth over 30 years, after that 30-year period, their GDP per capita will be $30,450. Huge increase in standard of living, but not yet even pushing up at the starting GDP per capita of the high-income economy. And so it's very important that, like, when we're thinking about convergence, we're recognizing the fact that all we're talking about is the relative pace at which these economies are growing. Not the fact that they're going to be the exact same standard of living at the end of it, just the relative growth rates here. And so those are the things you want to keep in mind when talking about convergence. It's one of the more detailed concepts. I don't assess it as much in this unit. Focus a little more on like the mechanics side of it. But if you have any questions, stop by during office hours or shoot me an email. Thanks.